What we're going to do in this tutorial is hands-on building an organ definition. And this is the only way you're going to be able to learn system programming is by doing it. You can watch this all day long, but you're never going to be proficient unless you actually do it yourself. And what we're going to do is we're going to build a relay one piece at a time. And we're going to start, now we have a definition file loaded in from the last tutorial, which was the basic elements overview of editing. And if we type KBD, you'll see that we have keyboards, and we have ranks, and we have pistons, etc. They're in that list. So what we're going to do is we're going to clear all this stuff out. And you can do this on your organ at home. And if we come back to the main menu, and we type clear, okay, you'll notice down here, clear, CLR, clear a definition type or item. So if we type clear from the edit menu, that will clear the entire definition from the organ. Press the enter key and it's gone. So now if we type keyboards, they're gone. Ranks, there's none there. Pistons, there's none there. So what we'll start with, if I can type right, is we'll start from the main menu and we'll go and we're going to add some keyboards, or at least one keyboard to start with. So we type /KBD, enter. We have a blank list, no keyboards are defined. So now we type add 1. There are no spaces required. Press the enter key. Now one keyboard has been added. So we have our keyboard designation, KBD. The element number is number 1, and it has a default name of keyboard number 1. So if we enter keyboard 1, we use our down arrow, come down to keyboard name, and we type in test. Now it can be any, you can give it any name you want, but we're just going to call it test so it doesn't conflict with classical or theater organs. We're just going to call it test. And we're going to give it the keyboard display so we can test things on our real-time keyboard display of item number 5, which is manual 2. Then we're going to come down to the 8-foot C of the keyboard, and we're going to type in the starting address number, in this case, which is going to be AA1, and it's going to be wired sequentially for 61 notes. So we type AAA1 left parenthesis 61 right parenthesis AAA1, which is our starting address where the cursor is highlighted, which is C of the 8-foot keyboard, and then we're going to add 61 notes sequentially from that starting address. So we press our enter key and all 61 notes have been defined. Now we can test this by tabbing back to the stop mode and typing run, and then come over here and click on our watch the keys, and you'll notice now we have a running organ definition with one keyboard, and we're able to display keys. So now if we come down and we close the window, type stop, and then go tab back into the editor. Okay, now we've added the keyboard. We're done. So now if we go back to the menu, next thing we want to do is add a rank. So type R and K, enter. There's no ranks defined, so we're going to use the add command again. Add 1, and now we have a rank 1. If we go into rank 1 directly, /RNK1, enter, and we come down with our down arrow to the rank name, and we're going to call this flute. Now generally there is a unit flute in every organ, in the pedal or someplace, and of course the theater organs, there's flutes all over the place. So we type in a flute. Rank delay time, we don't want to put any delay time because we want this to be in real time, full-time operation. And then we come down here into our programming screen and we go into the, let's make this a unit flute from 16-foot pitch, starting at 16 foot, and then going up for, let's say, 73 notes. So we're going to start this at output board address AA A1. It's going to be wired in sequential order from that starting address at 16 foot C for 73 notes. So we left parenthesis, 7-3 right parenthesis. And now when we press the enter key, we have wired all 73 notes starting at 16 foot pitch through the 4 foot top C of the keyboard. Okay? Everybody follow that so far? Now, if your wiring address, and you should put in your own wiring addresses for your flute, and we're just using this as an example. Now, let's say, for example, your flute bridges between two boards, okay? And your flute address has a 16-foot offset for 12 notes on board AA, and it's going to be on AA K1, and it's 12 notes long. Okay, so you type AAK1, you highlight the starting address, which is 16 foot C, and then you type in the starting address there, AAK1, and it's only going to run for 12 notes. So you push the enter button, okay, and you notice now that this part of the rank has changed, AAK1, and it has gone through L4, 12 notes. And now, at low C of the keyboard, you move the cursor over to there with the right arrow key, okay, and then you type AA A1, and then this is going to be wired sequentially for 61 notes. Okay, then press the enter key, and now you have reassigned the wiring. You have a split note here, and then your AAA1 is your starting address. So you have 61 notes in that order, and then the offset is at the upper portion of the output board, but it's actually the 16-foot octave here. Now you can come back over here, and if that particular board was on AC D5 for 12 notes, okay, then you just put in the note here, and or if it went from AC D5 for 5 notes, you put that there, and then you came 1, 2, 3, 4, 5, and then the 6th note started at A D B5 for 7 notes. Okay, and that's how you go in and you can broadcast wire without having to do individual wiring addresses. The lower part of the rank started ACD5 for 5 notes, and then the upper part of that octave went to ADB5 for 7 notes, and then the chest pipes, the pipes that are on the chest, go sequentially for 61 notes. So you can use the auto wiring feature anywhere and with any number of notes, and just as long as you start on the note you want to begin with and then put the number of notes that you have sequentially wired in the parenthesis, then it will put them in automatically for you. The only thing it will not do is if you have C and C sharp diatonic chests, you can't skip every other note, and for those type of chests you would have to put all the wiring addresses in by hand, and we're working on changing that, but it's rather difficult to do. So anyway, now we have a flute that is wired in, and you'll notice if you've done this on your organ and your blower and rectifier are on, that when you move this cursor around the outputs, the note plays. So what we'll do here is on this particular setup we're going to use MIDI, and I'm going to set up a MIDI so you can actually hear some of these notes play. And so we'll take a little break, and then I'll come right back, and you won't know I've been gone for as long as I've been gone. Okay, I'm back. See, it didn't take any time at all. Now what we're going to do is we're going to say that we have on this particular flute, which will probably come out as a piano, I'm not sure, but we'll see. We're going to put the offset on here as a MIDI offset, and we're going to put it on channel 1, MIDI channel 1, and we're going to start it at 16-foot pitch. So MIDI channel 1 is designated as MA. M for MIDI, A is channel 1. D1 is our starting note, 16 foot, and we're going to go for 12 notes. So you can hear that. And then it would go into the flute. Now if I come over here and get to channel 1, and make this a flute, there it is. Okay. I don't know if you can hear that or not. You should be able to. But now we have a flute. And if we come over here and we want to continue that to MAE5, which would be the 8-foot pitch, and go through 61 notes. Okay. Okay, now we have a rank built, and you should be able to do the same thing on your organ. So next thing we want to do is go back to our menu, and we want to assign this a stop. So we go to STP. There are no stops, so we once again want to add one. Now we've built a stop. Go to the stop number, STP 1. Doesn't have a name. Now the computer's going to build a name automatically from what we've already put in, the keyboard name and the rank name. So all we have to do is make a stop type. Now there are 4 or 5 different, I believe 5 different stop types. We'll go through all 5 of them. First one is a button or a switch. Now this can be a toggle switch or it can be a momentary button. Stop type 2 is a dual magnetic stop. And this is usually a stop that is either pneumatically or electrically activated, and it has a combination action movement to it. Third type is a reversible button, and this is a push on, push off, or what is called a lock and cancel. Fourth type is a dual contact draw knob, and this is a lighted draw knob, mostly used by Rogers, that has an on contact, an off contact, and an indicator address. Okay, and there are only 4 types. I was wrong. Okay, so we can pick one of these 4 types, and what we'll do for this purpose is, since this is a speaking stop on the console, we will use dual magnetic stop tab. So the first thing we want to do is come down to where it says the stop contact address. Okay, this is where your stop is going to be, and you can use any stop on the organ. You can use one in the grate, you can use one in the pedal. It doesn't really matter. We're just going to do this one element at a time. So let's use, you can pick any stop input address you wish. I'm going to use the first stop on my setup here, which is input address AAI1. Enter. Okay. Now, we can come down here and we can program in the on and off addresses for the stop magnets. You can do that now, or we can do it later. An indicator address is not really used on a dual contact knob because its movement indicates its position and it needs no external indicator. The output function, we're not going to worry about it this time. Debounce time, if you have real crummy contacts, you may want to put a debounce time here. I would not go more than 50 or 100 milliseconds. If it's a sealed reed type of stop action, you need no debounce time at all. Now the last 2 elements of the stop is combination action status and record play status. Now normally they're in the active mode, but if you wanted to make this combination action status inactive, then you can just toggle it, or you can type in a number 1 and that will make it inactive. Number 2 will make it active again. or you can use the large plus key on the number pad of your computer keyboard. That's the little number pad way to the right that has a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and numlock key. And you'll notice the very right, far right to the keyboard, there's an enter at the bottom, and then above that is a very large plus key button, and then above that is a very small minus key button. If you use the plus button and toggle that or push that, it will toggle it between active and inactive. Okay. Record play status. If you did not want this particular stop to record, you could do the same thing. You could make it active or inactive. Just there again by moving the cursor down and using the large plus key of the number pad, and you can toggle the different selections. So now we've got a stop defined, and what we can do now is we can go back to the stop mode and we can type console. Push the enter key, and now we can go and turn that stop on, and it is assigned as stop number 1, AAI1, stop 1, and it has no name. Okay, so we know it works. Press the escape to get rid of the console mode. Press the tab key to get back to the menu. Now, what we have to do is we have to assign a function to this key, the stop key. So we come down here and we see output function. So this is where we link or attach a function to the hardware. See, for now, all we've done is created hardware. We've created a keyboard, we've created a rank, and we've created a stop. Now we have to do some computer magic and tie all these together, and we do that through what's called a function. So if we go to /FNC, you'll find we have no functions defined. So we want to add 1, and that brings up function number 1. So we go to function number 1 to define it. So we type /FNC followed by its element number 1. Now we come up with an inactive. Now there are some 45 different types of functions in the system. We're going to start with the simple ones first. And once again, by moving the cursor down to the function type and going over to our keypad and using the large plus button, we push it once. We don't want to do that. Push it once, and that will bring up the first function type. Notice this is function type 1 here, and it puts in a bunch of blanks for us and gives us a function type, which is a division coupler. Well, we don't want a division coupler for this particular stop. Number 2 is a rank-to-rank coupler. That's function type 2. We don't want that. And we keep pushing the plus button until we find the function that we want to use. Function type 3 is a normal rank output. And you can see by the information that it asks for, or where the blanks are, this is what it will do. It asks for a keyboard, and it asks for a rank. It's already set up for an 8-foot pitch, and it'll ask us for an optional bottom note limit and an optional top note limit. Okay, so what we want to do is bring our cursor arrow down to keyboard. Okay, now what we can do is we only have one keyboard defined, so obviously it's going to be keyboard number 1. So what we do is we enter the key element or keyboard element number just by the number itself, because we know it's a keyboard. So we just put in the number 1. Press the enter key, and that brings up test keyboard, and it also identifies it as KBD or keyboard number 1. Now if we push the delete key, we delete that, and if we come over and use our right number pad plus key and we push it once, it brings up keyboard 1. Okay, and if we keep pushing it, that's the only one there is, so it's not going to toggle anymore. There's only one keyboard. Okay, then we bring the arrow down to rank, and we do the same thing. We've only got one rank defined, so it can only be rank number 1. Enter. Now we've just built this function. we don't have to add any more. We don't have to put any more information in because now it's already at an offset of 8 foot, which is standard. Every function that comes up is going to be coming up at a standard pitch of 8 foot if it requires a pitch. And you can change that if you want, but for now we're just going to leave that 8 foot. We don't have to put a top and bottom note limit in it. That's primarily only used when you're building resultants. So now what we've done, we've just built that by filling in the blanks, just by providing the information that the function wanted. So if we tab back to the stop menu, or to the stop screen, and type run, that will compile all of this information. And now if we turn that stop on and go over to our keyboard, oh, no, we left out one thing. We've created the function, but now we have to go back to the stop and place that function into the stop. So we type stop 1, okay, and then we come down to where it says output function. And there again, it's looking for a function number. So we don't have to specify a function, we just have to type in the number. So we type the number 1, press enter. And now it came up with the 8 foot test flute, function number 1. So now we have a stop with a function inside, or a connection to a function. So now if we go and type run, and we go over to our keyboard, voila, it plays. Okay, so now let's go back and type stop. Let's go back and change the pitch. So we tab back into the editor, and then we want to go to function 1. We don't want to change any more of the stop. We want to go to the function and change it. So we type FNC1. Okay, we bring the cursor up to the pitch. Now, pitches are in offsets, and that is a 0 offset means it's 8 foot. It's unison, and all these offsets refer to the lowest note of an organ keyboard. So an offset of 0 means low C, or unison 8 foot pitch. If we want to make a 4 foot pitch, we would type an offset of 12, positive 12. So we don't have to enter positive numbers, we just type the number 12. And when we press the enter key, then it shows us that the pitch offset is plus 12, or 4 foot. Now if we enter 24, okay, and that's going to move it 24 notes from low C of the keyboard. That's going to make it a 2 foot pitch, so on and so forth. Now, you can also use the plus and minus keys of your computer number keypad, and if we want to make that 25, 26, 27, and it will always show the current interval. If we just increment one at a time or decrement one at a time, it will always show us a standard organ pitch when it gets to 1. Like an offset of 28 notes is a 1 3/5 pitch. If we use the minus key and come backwards or come down, there's 2 foot. There's 2 2/7 at 22, 21, 20, 19 is 2 2/3, 16 is 3 1/5. So if you don't really know the pitch, you can just use the plus and minus keys and just keep pushing them until you get to the pitch you want. 4 4/7, so on and so forth. So we wanted to make this a 4 foot pitch, so we put the offset at plus 12. Now if we tab back to the stop menu and then we type run. Now what that's going to do is when we type run, it recompiles all the information, goes into the run mode, and now it plays it at a 4 foot pitch. So we've just essentially built a keyboard, a rank, a stop, and a function, and made the organ play. Pretty simple. Now let's go back and add a second stop. Type stop, tab back, go to our stop screen, STP. We have one stop defined. Now we want to add 1. Now we have stop 2. So we go to STP2. Come down, we make it a type 2 dual magnetic stop. We come down to the stop contact address. We put in the input address for the stop number 2. In this case, that's AAI2 for this test machine. And then we want to go to add a second function. So we go to function, and then we type add 1. So we put a second function there. Type function 2. We come down, and we then select the function type we want. Division coupler, no. Rank to rank coupler, no. Normal rank output, yes. So we come down to the keyboard, which is number 1. The rank, which is number 1. And the offset, which is 8 foot. Okay, so now we have an 8 and a 4 because we already made the stop number 1 a 4-foot pitch. Now stop number 2 is going to be an 8-foot pitch. So now we've made the function. Now we go back to stop number 2, and we go down to the output function and we type in the number 2 because it's looking for a function number, and that's 8-foot test flute. Okay, so now we go back to the stop menu, type run. And now we have the 4-foot. And then we turn the 8-foot stop on. So this is what we're going to do in the subsequent tutorials. We're going to take one function at a time, and we're going to build one thing at a time until we go through everything in the function list, or at least the most common things. There's some things in the function list that aren't used in normal organ operation. They're reserved for other things. And but we'll cover most of the functions that are in the system. The next tutorial will go through the function list and show you exactly what all the functions are, and show you how to print them out so you can have your own selection of printable functions that you can keep in a notebook for easy reference. So with that, see you next time.